work shown for these questions. Of course, whoever wrote the quiz certainly knows that they put this in the calculator active section. It's not a big surprise that you would use the calculator to your advantage, right? You'd be expected to do that. So for letter A, we'd go integral from 2 to 4. For displacement, do we need to consider the absolute value of velocity, or do we just leave velocity as is?
As is.
Yeah, we do. We leave it as is, whether velocity is positive or negative or zero. Displacement's going to account for all that. And so we would just put v of t here, or if you wanted to put the whole expression, you're welcome to do that. And then don't forget your dt really has to be there as well. If it's not there, you want to definitely get into the habit of it being there. So you write that out, and then of course you immediately turn to Math 9. Hopefully you were in radian mode when you do this. And to 3 decimals, which is our standard, what would you guys get? 94 something I saw? 94.494. So do keep that in mind, 3 decimals always, if you go to a decimal approximation for that. So displacement apparently is that. I did not give you any units here, so let's not make any up or put like U or something like that, right? Or units. So for letter B, it'd be integral from 2 to 4. And when we're looking for distance traveled or total distance traveled, this is where absolute value needs to be considered. So this would be absolute value of velocity and times dt. And we would then, of course, turn to Math 9. And as several of you pointed out, did you guys all get the same number, the 94.494? You did? Okay, cool. So 94.494, that would be the total distance traveled. And I heard you guys talking about the conclusion, and I think you made some really good observations. If displacement and total distance traveled are the exact same number, like this, what had to happen, or more accurately, what didn't happen?
It never retraces.
Yeah, never turned around anywhere, right? Never retraced its steps, never turned around at all. It just went in one straight line in the positive direction, apparently, and that's it. Question?
Are there equations for like if it didn't retrace its steps, but it went like, say like this was the starting point and it went like 10 units this way and like 10 units that way, like this would be the displacement, but like that would be the distance traveled, like
Yeah.
is that like
So that's a calculus 2 question. So in our class, the particles either go left and right only, or they go up and down only. And so we figure out our total distance traveled, our displacement based on that. But in calculus 2, so like this is just one dimension. This is just one dimension. In calculus 2, they can move left and right and up and down at the same time. And so we'd be finding like the length of that curve that traces their path. Totally doable. There's another question you could ask. Do you know what it is?
Well, if it goes...
I thought you were about to say it.
Well, would you go, if you went backwards and then made up for it on that same interval? I don't know what I'm trying to say.
Well, okay, so if you went backwards and then made up for it.
You still end up in the same
What? So let's okay. So that's not quite what I was getting at, but let's talk about it. So what if I started here, I went backwards, and then I retraced my steps? What's my displacement?
It's gonna be
0. What's my total distance traveled?
2 times the distance?
Yeah, whatever that distance was, we double it, and that's my total distance traveled. Right. Okay. So Anna said, "I know about this, and I know about this, but what about this? What's the other? Well, we actually do. We use distance formulas. I'll show you. So here's how you find total distance traveled. Check this out. If we're doing 2 dimensions, right? It's not on your quiz. None of this is directly on your quiz. Not even in this class, right? Not even in this course. Just FYI. So clearly an integral, right? Because you're adding up a bunch of little tiny distances. Be the integral from A to B. And it would be the x velocity squared, so like the horizontal velocity squared, plus the vertical velocity squared. Yeah. And there'd be a little dt on the end there that I didn't have room to put. So do you see the distance formula there? Which is a triangle. But we're just going to take those 2 distances and shrink them way down so the hypotenuse is really tiny. And just add up all those itty-bitty tiny hypotenuse, and you get the total distance traveled. Okay, so nobody asked it. So this is calculus 1.
Oh, is there? a
Which is
calculus
what you
like
guys are
dimension?
doing.
Is that it?
Calculus 2, the particle does this. Calculus 3, the particle goes towards you and away from you and up and down and all over the place.
Deals with the force.
Just adds one more dimension. A lot of
Is there a
formulas.
fourth dimension?
Well,
Some people say time.
yeah, I mean, you can think of it. You can certainly think of other dimensions, other parameters is what you'd probably call it. But anyway, I don't know. It just adds one more dimension. So it's I'd say,
Just one.
I would say that it's probably, I would say that it's more laborious than it is like more difficult, right? Of course, the extra dimension adds a layer of difficulty, but it's more of just like, oh, this is just like this with one more dimension. And you just have to adapt your old learning to your new learning. And I mean, I'm not saying that it's like so easy that you could do it in your sleep. I'm just saying that it's like if you understood the basis for it, you can translate that knowledge into the new stuff and make some adjustments and you'd be okay. So, all right, excellent.